Hi guys, welcome back again to the tutorials. In this video, we're gonna solve another problem in thermodynamics and heat transfer, chapter 10, heat transfer by convection. Our example: during air cooling of potatoes, the heat transfer coefficient for combined convection, filtration, and evaporation is determined experimentally to be as shown. So our question is: consider a 10 cm diameter potato initially at 20 degrees Celsius with a thermal conductivity of 0.49 watts per meter times degree Celsius. Potatoes are cooled by refrigerated air at 5 degrees Celsius. At a velocity of 1 meter per second, determine the initial rate of heat transfer from a potato and the initial value of the temperature gradient in the potato at the surface. So first, let us identify the given in our examples. We have the diameter is equal to 10 centimeter. Our temperature of the surface is equal to 20 degrees Celsius. Our temperature of the fluid sufficiently far from the surface is equal to 5 degrees Celsius. Our convection heat transfer coefficient, we have 19.1 watts per square meter times degrees Celsius. We have the thermal conductivity of the potato. A is equal to 0.49 watts per meter times degrees Celsius. So we have the velocity is equal to 1 miles per second. The initial rate of heat transfer from a potato is heat transfer surface area is equal to pi d squared. That is equal to pi. Our diameter is equal to 0.10 meter squared. That is equal to 0.03142 meter squared. Next, let us find the rate of heat transfer is equal to convection heat thermal efficiency times the surface convection heat transfer surface area times the temperature of the surface minus the temperature of the fluid sufficient far from the surface is equal to our heat transfer coefficient is equal to 19.1 watts per square meter times degrees Celsius times the surface area is equal to 0.03142 square meter times our temperature of the surface is equal to 20 minus the temperature of the fluid extremely far from the surface, 5 degrees Celsius. So cancel the watts. cancel the meter squared, square meter, cancel the degree Celsius. So our rate of heat transfer is equal to 9.0 watts. And then, where the heat transfer coefficient is obtained from the table at 1 miles per second velocity, the initial value of the temperature gradient at the potato surface is, so Q convex is equal to Q conduction, that is equal to negative K times the temperature gradient at the surface AR is equal to heat transfer coefficient times the temperature of the surface minus the temperature of the fluid which is being formed from the surface. So since we are looking for the gradient of the surface, so gradient on the surface is equal to the height, heat transfer coefficient times the temperature of the surface minus the temperature of the fluid efficiency on the surface, divided by the thermal conductivity. Okay, so let's plug in the given in our equation. So we have 19.1 watts per square meter times degree Celsius times our temperature of the surface is equal to 20 minus our temperature of the fluid, 5 degrees Celsius, divided by our thermal conductivity equal to 0.49 watts per meter times degree Celsius. So cancel degree Celsius, the meter, the watts. So the answer for the temperature gradient at the surface is 585 degree Celsius per liter. So this is our answer.